Imagine a star so dense that a teaspoon of its material would weigh 1 billion tons. Born from the dramatic death of a massive star, a supernova explosion, these stellar remnants are the densest objects in the universe, second only to black holes. The core of the dying star collapses under its own gravity, squeezing protons and electrons together to form neutrons, creating a neutron star. And when two of these incredibly dense objects meet, it's a cosmic spectacle like no other. When two neutron stars orbit each other, they emit gravitational waves, spiraling closer until they collide with a bang heard across the cosmos. As these celestial titans dance, they perform a cosmic ballet of gravity and time, tugging at each other, their orbits shrinking, their speeds increasing. This dance is not eternal, though. These stars, each more massive than our sun, but compacted into a sphere just a few miles across, eventually meet in a cataclysmic finale. This is no ordinary collision. It's a clash of unimaginable forces, a maelstrom of warped space-time and extreme temperatures. The universe holds its breath as the stars collide, and in that moment, energy equivalent to the mass of several suns is released as gravitational waves. These waves ripple outwards, distorting the fabric of the universe, and the result? A spectacle brighter than 1 billion suns. These collisions release immense energy, creating gold, platinum, and other heavy elements. In fact, nearly all the gold and platinum on Earth originated from these cosmic explosions. When neutron stars collide, the intense pressure and temperature forge atoms into these precious metals. The aftermath sends them hurtling across the cosmos, enriching galaxies with heavy elements. It's a celestial alchemy on a grand scale. But the spectacle doesn't end there. The collision's force can be so powerful that it collapses the merged neutron star into a black hole. These black holes are the universe's ultimate recycling bins, where matter disappears into a gravitational singularity, a point of infinite density. It's a place where the laws of physics, as we know them, break down, and time and space cease to exist as separate entities. Some collisions are so intense they create black holes, the universe's ultimate abyss. These celestial events help scientists study extreme physics, shedding light on mysteries like gravitational waves and the origin of heavy elements in the universe. Each collision is a cosmic laboratory, allowing us to explore conditions that can't be replicated on Earth. They provide clues about the fundamental laws of nature and the very fabric of space-time. As we delve deeper into the cosmos, neutron star collisions continue to challenge our understanding, driving us forward in our quest for knowledge. With advancing technology, we are poised to uncover more secrets from these cosmic giants. Neutron star collisions remind us of the dynamic and ever-evolving universe we live in. These cataclysmic events, happening billions of miles away, echo through the cosmos, reaching us here on Earth. In their grandeur and power, they illustrate the fundamental laws of physics at their most extreme. They are the universe's most impressive fireworks, painting the celestial canvas with light and particles, creating elements heavier than iron. These collisions, though violent, are a creative force, a cosmic forge where elements are born. They serve as a testament to the cyclical nature of the cosmos, where death leads to birth, chaos births order, and destruction paves the way for creation. In all their might and spectacle, neutron star collisions are a humbling reminder of our place in the cosmos. We are part of this grand cosmic dance, made from the very elements forged in these distant celestial collisions. These cosmic events are not just astronomical phenomena, they are spectacular reminders of our place in the cosmos.